Welcome everyone to the chapter 3 of A Brief History of Time book, The Expanding Universe. Chapter name is The Expanding Universe. This chapter is all about the universe is expanding. Our universe is ever expanding and how this discovery led. As I know, Albert Einstein discovered general relativity in 1915 and the solution solved by uh, Alexander Friedman, a Russian mathematician who solved the Einstein's field equation, the equation of general relativity, and gave us the solution that our universe is dynamic. It's not static. Our universe is or expanding or contracting. So this chapter is all about the expanding nature of the universe and the discoveries into the heart of the expansion of the universe. You can see here is the photograph of galaxy, and here is the uh, photograph. You can see there the expanding nature of the universe is described. Some of the things you can also see in this chapter. Now here this chapter has also a discovery led by Stephen Hawking. All we have know, this is the chapter Expanding Universe. You can see here is the photograph of Isaac Newton, who led the experiment of glass prism that split the ray of white light into 7 colors spectrum. And you can see here is the spectrum, and these are electromagnetic waves, the classification of electromagnetic waves and the basis of the wavelength. And this is the spectrum. You can see this is the chapter of Expanding Universe. Here is the photograph of two astronomers, astrophysicists or cosmologists, Enro Penzias and Robert Wilson. Both are at Bell Telephone Laboratories, done a very important experiment ever, that they receive the light wavelength, electromagnetic wavelength from outer space, from every direction of the space else, and they concluded that the um, electromagnetic wave which they receive is the microwave background radiation from the universe, from the whole cosmos they receive. So that's the discovery of cosmic microwave background confirmed, and this is very minor Kelvin, 2.71 approximately, very minor Kelvin. So this was the discovery led by Enro Penzias and Robert Wilson, which won him the Nobel Prize in Physics. And here is the illustration of how our universe is expanding. So you can see here is the balloon, and in which um, there is some galaxies pointed out, and this balloon while expanding, then the galaxies going far and far, you can see. And this is the graph of the closed universe, that the Big Bang happened, and after the course of time, it reaches the most um, what I would say most expansion, and at last it will uh, collapse into a big crunch. And that's what we know, Big Bang Theory, the birth of the cosmos, and the big crunch, that's the death of the cosmos. That's the closed universe concept described in this graph you can ever see. Here you can also see that some of the graphs is given here to describe the Big Bang and open model of the universe and flat model of the universe, you can see. And you can also see in this photograph that here is the closed universe concept, how open universe is going to expand forever and not stop to expand and then contract, but the closed universe um, expands and fixed at the course of time and recontract with the course of time and at last collapse into the big crunch. So this is the difference between open universe and closed universe, you can see here. And now here is, you can see some of the explanations how Friedman model of the universe is correct, should be correct. And these are the three photographs of astronomers who developed the steady state theory. You can see here the photograph of Fred Hoyle, Thomas Gold, and Herman Bondi. Here is also the photograph of as the universe expands, new galaxies are continuously formed to maintain its density. So this is the steady state theory, which is mathematically self-contractible, um, proved by Stephen Hawking in his doctoral thesis. And here is the photograph of Roger Penrose, who is the recipient of 2020 Nobel Prize in Physics, and he is the theoretical mathematician Roger Penrose, photographed at Oxford in 1980, who developed the gravitational singularity theorems for black holes. And here is what the photograph of Stephen Hawking at Oxford University in 1962 during his Oxford graduation. He further developed the gravitational singularity theorem for the whole cosmos of Roger Penrose. The singularity theorem of Roger Penrose, which was for black holes, but he developed for whole cosmos. And you can see here is the um, graph and diagram which explains how a star collapses into a black hole singularity, and here is a singularity expanding into a universe. So first of this diagram explains the Roger Penrose idea of black hole collapse, a star collapse into a black hole, which is the black hole singularity theorem. But the B diagram explains out the whole universe, how a singularity expanding into a whole universe, and that was discovered by Stephen Hawking. And this is what you see here is the um, a singularity is expanding into a whole cosmos, whole universe, and a star collapsing into a black hole singularity. So this is the explanation of singularity theorems developed in 1970 by Roger Penrose and Stephen Hawking. This was the wonderful discovery which reborn the ideology of Big Bang Theory. And here is the chapter 4, which I will describe you in next video.